Welcome, welcome, welcome. I'm Jeffrey Palermo, your host for this webinar, and I'm also the Chief Architect of ClearMeasure. We are a software architecture company focusing on empowering software delivery, and I'm really excited that you're here today. We have a great group on this webinar. I'm here to present a DevOps Jumpstart for new .NET applications, and it's important to get your project off and running on the right track and do things right from the start, because you need to move fast. You need to build your software in a smart manner, and you need to run your system with confidence. And so we're going to be here focusing on the project start. And regardless of the challenge that you are facing, just judging from the job titles here on the webinar, a lot of leaders here, you have an important responsibility as a software leader. And my hope for you is that you'll be able to take away some information that can help your new project succeed. There's a few logistics here. My webinar assistant is going to be putting some information in the chat window, and you can also ask questions in the Q&A panel. I'm pretty good about working in the answers to the questions during the content, but my commitment to you is that I will not close out the webinar until all the questions are answered. And I will give you my phone number and email address at the end of the webinar so that you can contact me and follow up. I want to make sure that you get off on the right track. And we're going to shoot for under an hour of content. I know we reserved an hour, but let's get right into the content. We are talking about a DevOps Jumpstart for new .NET applications. And the webinar is organized like this. And we're going to talk about the objectives that we all share when starting a new project, the challenge that's in front of us, how important speed and quality are, and then what results that you can expect and you should look for. So an important resource right out of the gate is my latest book. It's finished last year, .NET DevOps for Azure. And as it turns out, even if you're not using Azure, even if you're on-premise or have a mixed environment, this book is for software leaders. It's for those lead engineers, architects. The first half of every chapter is architectural principles, and then the second half is how to apply those on the current Microsoft tooling for DevOps. And it comes with a pit of success configuration. There's a public project, the link's there on the screen. And it is also the basis of a new quarterly boot camp training. This is hands-on, immersive boot camp style training in Austin, Texas. I am the trainer, and the next class is April of 2020. Just go on our website to look at that. Also, you might be interested in the podcast, the Azure DevOps podcast. You can go to www.azuredevops.show. Many of you are already podcast listeners, but if you are not, just look it up in any podcast directory or directly off the website. And we have some fantastic interviews, fantastic shows there. So let's get right into our content. We are starting a new project. The most important thing is to jumpstart straight to productivity. You don't have months in order to get out the first skeleton version, the minimum viable product, whatever you want to call the first version. And it's important to get out the first build, the first release candidate, because that is going to judge how much speed you carry forward to actual product launch. You want to get this startup stuff out of the way as quick as possible. You want to be done with it before you start working on feature development. If you still don't have this stuff up and running and your people are trying to work on features, then you're just going to be walking through the figurative tar pit. Now, there is a big challenge, and complexity is our nemesis. Complexity is our enemy, and we have to fight complexity every step of the way, not only from requirements complexity to how we implement it. And there's various types of complexity we have to deal with. There's the logic that's going to be a part of whatever our application does. There's going to be scale or performance at scale complexity to make sure that the application stays up and running. There's going to be data structures and the interrelatedness of data. We have to deal with that complexity. And then the architecture, putting in place a design that's going to meet the need. And we have a lot of choices to make. We have to get beyond the it depends. We have to actually make choices. And it can be confusing. And so we need to navigate through that. Now, there's a industry dynamic that is influencing everyone. And the 2018 Stack Overflow Developer Survey kind of brought this years coding professionally graphic, and you can find that in their survey. This is taken from there, but notice the heavy percentages at the top in the 0 to 2 years, the 3 to 5 years. If you look at it, over half of our industry started in the industry after 2012. And so that means that all of the industry practices that happened before 2012, it's up to the college programs and education programs to educate these new professionals on history and lessons learned of the past. And in a lot of cases, the boot camps or the coding schools don't have the time to go into that, and the college programs are not all the same. So we just have something that just as software leaders we need to be aware of, because I certainly take for granted some lessons that I learned in the mid to late 90s and some things that were going on, and then having benefited from seeing several iterations of technology where even as we have new technologies come along and there's a lot of new stuff, there's a lot of old problems. And how just in my career so far, we've reinvented the wheel multiple times over and done it a different way, but the thought process around the problem has been the same. And so starting up a new project, this is one of those things where new software projects have been started for decades and decades and decades. So it's not a new thing to have a plan for starting up a new project. Now, let's talk about DevOps, because it certainly is a buzzword, and it certainly is a solution, and it certainly has a lot to bring to the table. However, DevOps is just a set of principles and practices, just like Agile. If anyone wasn't doing Agile at the time of 2001 when the Agile Manifesto came around, it's the same thing. It's a set of principles, and then the practices were later on. Now, this diagram on the screen on the left, it's a conventional view of DevOps, and it calls out that we set up an automated continuous delivery process that goes from plan, create, verify, package, release, configure, monitor, and then going back to plan. And I don't like this. I don't like that it calls out Dev and Ops being separate, because then people bring up, oh, what about QA? What about project management? What about security? What about everything else? And so it doesn't work. I like to untwist that diagram and make a single cohesive cycle, and every skill set, every practice that is necessary for a successful project, it is within one team, and we have one cycle. And now in the center, we have the automated DevOps pipeline, which is kind of the core of the technical practices. All the technical practices hang off of the automated DevOps pipeline, which is the promotion of ideas through a process all the way to our customers or users. Now, the model, we have a model called DevOps centered software engineering that layers on some additional capabilities that your organization needs to have beyond just automated builds, CI, CD deployments, and all the essentially the sexy buzzword stuff. And of these layers that we define around the DevOps pipeline that drive our ability to execute a cycle time, each of these must have a sound strategy, be executed with discipline, and have objective measures. It's not enough to say, for example, that you've equipped your team with defect removal without specifying how and why. Capers-Jones has a lot of research that he's published over the years, and his research spells out the combination of defect detection methods that are proven to achieve very, very high quality in a consistent manner. And so if we don't take that into account, if we're just winging it, then we're going to reinvent the wheel, and we're going to have ongoing defect problems. And defects are essentially work that generates rework. So it's work that doesn't actually get us down the road. We need to burn down the amount of work that's remaining as opposed to just switching new work for rework. So I want to talk about the overall structure real briefly. I know there's a lot of small text on this screen. This is a portion of a DevOps architecture poster that we use in a lot of our client engagements, and it goes through the high level stages of any DevOps pipeline, all the way from source control and an individual developer to private builds, integration builds, talks about how to do package management and managing release candidates, how to promote across the 3 unique types of environments. There are 3 types of environments. You need at least 1 of each type, and therefore no pipeline will ever be fewer than 3 environments. You need at least 1 production environment. A lot of companies have multiple production environments if they deploy an instance of their system per customer. You can also have multiple test environments. That's fine, but a test or a manual test environment is a type of environment. And then you also need the test automation environment that we call the TDD environment. TDD stands for test driven development. This is the top third of an architectural poster that we'd like you to have. And so if you'd like to have it, then just click on the link in the chat. And this happens to be a poster that just calls out some key products. That is Azure DevOps Services and Octopus Deploy married together. There's many different permutations of tools and technologies. A lot of people like to use TeamCity for the build server or Jenkins. A lot of people like to use release management for deployment. A lot of people like to use Octopus Deploy. A lot of people like to use Redgate SQL change automation for database migrations. So there's a lot of tools. We don't focus so much on tools first. We focus on the architecture first. But here's a resource that you can, this is only the top third of this poster. It's a pretty large poster. You can get it printed at your print shop, however you like. Now, when creating your new project, it's important to get your process down from the get-go. And I want to focus on the top row here. And we find this a lot of times missing in work tracking processes for any kind of application someone may be building. People tend to focus on having continuous integration, which we'll talk about why it's implemented improperly in a second. But there are 4 unique types of design decisions that must be made on a particular software idea or an idea for a change before it's ready to go to a developer. And the first one is figuring out what the conceptual definition is. These are determining the high-level use cases, the business objectives, and across these 4, we break requirements into 4 pieces because they really are individual decisions. And after we figure out what the heck we're building, that's conceptual definition, why we even need to make a change, why we need to add a feature, add a new software behavior, then we ask ourselves, how do we want a person to experience this new behavior of the software? And for screens, obviously wireframes would go there, but if we're moving data from one application to another, then timeouts and service level agreements of data movement would be part of the user's experience, because if a user needs data to be over in a separate system within 30 seconds, then if they're still waiting there 5 minutes later, that's not a good user experience. After those decisions are made, then technical design comes into play, and that is augmenting the current architecture. If we discovered any new architectural elements that need to be added in order to support this new software behavior, and then after that, or in technical design also, this is where we ask ourselves, do we need to bring in any more NuGet packages or design patterns, things like that. We might do a skeleton proof of concept of a new pattern in the software if this is a new and novel idea. If we're just adding an additional behavior, additional screen, or additional report, and we've done dozens of those before, then we're going to blaze right through and we're just going to say, oh, it's another report. We know how to do reports next, and it could be really easy. And then the final design decision is the acceptance criteria or the test design. And that is the definition of done. This is the perfect place for Scrum's acceptance criteria. And this is literally a bullet point list of steps that you should be able to do on a manual basis to know that the software works well. Go to this page, click here, pull up this screen, check something else. Literally prescriptive, just a set of bullet points. Really, really simple. But it's important because the test design enables us to complete a continuous integration implementation by automating those test scenarios using a full system test framework like Selenium or another appropriate one. And then immediately after a build, we do a automated deployment and then run all the tests. And now we have completed our continuous integration implementation. If you are someone whose team says we have continuous integration in place, you can do a quick inspection and make sure and check to see if there is an automated deployment immediately after the integration build to answer the question of, will the application still start up? And does the application's main capabilities still work? If we can't get that answer quickly and automatically, then our continuous integration implementation is not complete yet. All right, so this is the overall process that you want in place, and you want a continuous flow process. In DevOps, we've learned that while Scrum was a good step forward away from 6-month and 1-year waterfall processes, we've shrunken our phases, essentially project phases. In the 90s, and Scrum, a lot of people probably on this call use Scrum. It was a response to waterfall processes that were literally doing months of design and then months of coding and then months of testing, and there were no deployments in between, and it was pretty crazy that the industry ever did it that way. But we need to move faster, and so sprints have started at a month-long sprint, and then a 3-week sprint, and then a 2-week sprint. A lot of teams now are doing a 1-week sprint. Now, if you take it to the next level and do a daily sprint, then you ask yourself the question, well, why are we even doing a sprint at all? Why don't we just have every change essentially be a unit and go to single piece flow? That is the Kanban stage. So that's process. You need to get your workflow down. Now, I'm going to blaze through a few other of these, and the order in which you need to implement these capabilities is workflow first, like we just said. You need a tracked process where you can see all the work in front of you, and if the work is hidden, it's gonna sap your schedule. If work is coming in via email and via support tickets and everything else, you may think that you have some number of developers dedicated to the project, but you actually don't. You have some smaller amount of labor actually dedicated to the project. All right. Now I want to talk about Kanban board design. When you're starting your project, you will likely not have fewer than 9 statuses, 9 columns. And this is really important because you see the conceptual definition, user experience design, how I kind of flattened out that flow that I showed earlier into a Kanban board. I don't care what you name these columns. Name the columns whatever you like, but make sure to capture the concepts and make sure that every column has a person or a role assigned to it. And notice how the number of pre-development columns are the same as the validation columns after development. The development column is essentially where the code is typed, where the programming actually happens. And by splitting out all this work, then you will be able to see very clearly where bottlenecks start to happen. If all you have is in progress, not started, in progress, and done, then you're not going to know why things are taking so long. But when you split it out like this, you can quickly see where the bottleneck is. We had a situation where a team had the user experience validation and release validation columns that were just chock full of cards, whether you call them product backlog items or user story cards. They were just jam packed, and one person was trying to do all that, and then you had 4 other developers that were happily coding away at additional functionality, just making the bottleneck worse. There was a whole lot of business value that was wrapped up in this work in process that was actually code complete, and the developers thought it was ready to go, but there was just that we needed to get through the actual validation to make sure that there were not any regression problems or whatnot. And so what you can do when you recognize those bottlenecks is realign all of the people that you have on the team. People need to be cross-trained. You don't want an over allocation of labor on a particular column that is exceeding the throughput of another one. So you need to move your people around. And even if there's any young programmers who are on this webinar, just know that your job is not coding. Your job is not programming. Your job is getting software to users in a production environment. And there's a lot of things that need to happen in order to do that. So make sure you move your people around. Make sure that every unique type of work in your process has an independent stage that is represented by a column in your Kanban board. And all of the project tracking tools support a Kanban style chart like this. The next thing you need to think about is defect removal, how you're going to make sure that quality is embedded into this process. A DevOps pipeline, the reason it's called a pipeline is to invoke the imagery of water. And water comes from some headwater source and then goes downstream and ultimately is consumed by people. We want fresh, clean, cool water for our users. We don't want there to be dirt or impurities in the water. So we need to put in place filters and treatments all along the way to make sure that any impurities that are there, any dirt, any filth is taken out of the water before it gets to the users, before it gets to our customers. The headwaters of a DevOps pipeline is the version control system. Though all the water flows from there, and every single stage from there is a quality control filter. So before code is written, we have quality assurance. And after code is written, we have quality control, because our prevention activities happen in the process ahead of which the code is actually written. After code is written, it is verification, and it is checking to make sure that no problems were introduced. So that's how to think of it. Now, Capers-Jones has a white paper called Software Defect Origins and Removal Methods. Back in 2012, you can Google for it and find the PDF. The title, again, is Software Defect Origins and Removal Methods. And in it, his research concludes that out of every 5 defects, almost 2.5 come from activities ahead of the actual coding, from requirements, problems, analysis gaps, design mistakes, and about 1.75 out of 5 defects actually come from coding errors. Interestingly enough, about 10% of defects come from bad fixes. So we want to prevent as many defects as possible. Now, let's talk about the build steps to get in place from the beginning. You want a private build and an integration build. And there are 2 different types of builds in continuous integration. The developer workstation, that is the private build. And the private build, you should be able to take that computer to the moon, not connected to any network, and it should be able to function. So every dependency should be managed in that build process. The build process shouldn't call out to a dev server, shouldn't rely on a shared database, everything necessary. So if there's a SQL Server database in use, then we need to have a SQL migrations routine so that the schema of that database can be created on the developer workstation by the private build. Then the integration build, or the CI build, a continuous integration build, brings together changes from multiple developers, and it makes use of the private build script because it has to do the same things. And it's outlined very much the same. A test in the test-driven development methodology is outlined with arrange, act, assert. Arrange is getting set up, setting up the environment so that we are ready to actually do our action, which in a build, the action is the conversion of text source control to executable code, which is the compile. And then the assertions are tests and other verifications. Static code analysis initially is not going to be an assertion if you're just introducing it, because you'll have tons and tons of warnings and errors. But over time, as you mature, you'll want to move the static code analysis box over to the assertion column. And after you've asserted that there's no new problems there and everything's great, you want to publish those test results and then package up the different deployable components of the application in deployable packages that together make up a numbered release candidate for the application. Now, when it comes to the entire continuous integration process, that is much more than just the integration build. I want to stress this. Continuous integration contains a build, but the build itself is not continuous integration. Continuous integration is a practice, not a automatically triggered compile routine. So what we see on the screen here is the complete flow of a modern continuous integration process. It starts with, we know our design and we're specifying test scenarios. The developer is going to change some code, execute the private build locally, push the code up to a feature branch. The integration build is going to operate on the feature branch. The build is going to execute. Then the results of the build is going to deploy to our test automation environment, the TDD environment, and the automated acceptance tests are going to run to verify that we didn't just completely break this application and that it still starts up, all the major functions still work. Then from our branch, we're going to create a pull request, and then someone from our team is going to execute the standard team inspection checklist and accept the pull request. That is a full flow of continuous integration where we, in a very short cycle, are integrating code changes with our mainline code branch, which in Git is named master. And until we have that code in master in a verifiably stable manner, we have not integrated. And the continuous means that we are able to do this very frequently, multiple times a day. So we should be able to go through this flow more than once per day. It's going to be different for everybody, but if you're not getting one or two or more of these cycles per day, then there's definitely room for improvement in order to implement continuous integration for your team. Okay, the next thing to think about is the overall practices. Now, there are so many practices that have been labeled as, quote, best in the industry that it is impossible to use every, quote, best practice on a given project. There's just too many. Some of them are not complementary. Some of them are either or. And so you will never be able to say, oh, I'm using best practices. Because then the follow-up question is always, okay, which ones? There's so many good practices to choose from based on your situation. Which ones have you selected? And so it's always a choice. And so when selecting the practices, the whole team needs to be aligned with which practices are appropriate for your given project. And that is the strategy, choosing which ones we're gonna use, because it's not even possible to use them all. So when someone says, oh, of course we use best practices, they're really not saying anything. But you definitely need to decide that when starting up a new project. I want to hone in on this part of the process here because this is going to be your short cycle time. You're going to design some test scenarios, develop the code that makes those test scenarios possible, and then you're going to validate it and you're going to do it over and over and over again. Then once you have a build, that release candidate is going to go across environments, and we want to set up the automated deployments in a fashion where you never do anything on production that hasn't been practiced or tested multiple times before on a pre-production environment. And so here are some of the steps that you're going to execute across the environments. And number 3 on that list, the run the health check, that is so important. We've all been in a situation where you deploy to a new environment and then it just doesn't even start up. The application's not ready to go, whether it was a configuration problem or something. But hey, maybe it worked on an upstream environment, but now you get down to the next environment and something just doesn't work right. So every single time we deploy, we want to ask the application. We want to ask every deployed component of that application. When I say application component, I mean something that runs as a memory space. A Windows service would be a deployed component. A Azure function would be a deployed component. A website would be a deployed component. The SQL Server database is a deployed component. You deploy that application, you're deploying multiple components. And each one of them runs in their own memory space, and each one of them needs to be online and healthy. And so we need to ask them, hey, are you online and healthy? Can you do what you need to do? And that is best to be baked into the code so that we can ask it. Now, for a Windows service, it may be a heartbeat. For a web application, it could be a diagnostic web API endpoint or a web service. But whatever it is for your application, there needs to be a way to ask the application, are you online and healthy? Now, I want to dive into the testing, the full system testing implementation with Azure DevOps. It is so easy with modern testing frameworks to take a screenshot of the application. And when we're running full system tests with Selenium, it's super easy just to take a screenshot. And so in this particular pane, we can see on the bottom right of the screen that we have a form, that this is pretty much the inside of a web page. The only thing we're not seeing is the browser's border around it. And we have a Selenium test that's typing in the text boxes and clicking the button and executing test scenarios. And we have step 1, step 2, step 3. And we're capturing screenshots of every step of the way. This is a really useful technique to put into the project from the get-go, because once things start going, you have schedule pressure, you're not going to be able to equip the team with these things, or it's going to be a lot more difficult later. And when something breaks, it's great to have the screenshots of what it actually looked like. That's going to cut down on your debugging and problem reproduction time. Finally, we want to have architectural blueprints. You want to align your team on what is being built. Everybody on your team is searching for that mental picture for what we're doing and what we're building. And a picture is worth 1,000 words. And if every person on the team has to convert 1,000 words to the picture in their own brains, they're not going to get the same picture. And so as a leader, make sure that you provide the picture for them. In 1995, Philippe Khrushchev, who then worked at Rational Software Corporation, created, or he wrote a white paper, and he proposed a model for iterative incremental software architecture specification. He called it architectural blueprints, the 4+1 view model of software architecture. And it's probably still to this day the best model that I've come across. And use Visio or PowerPoint, it doesn't even matter. You can even use a whiteboard, but essentially you depict the application from multiple viewpoints. And the 4 different views are physical or runtime, how it's going to run in the target environment. And then logical, how does it look like from a logical perspective, and a Visual Studio project structure closely aligns with logical. Third is process. What direction and sequence does data flow through the application and onto dependencies whenever you execute the major capabilities? And then the fourth layer is the development view, which is all of the systems that are in place that enable a development team to maintain it, grow it, develop it. Your DevOps pipeline is definitely part of the development view. And this, everybody knows intuitively this is so important, because when you bring a new developer on the team, sometimes it takes a while for them to learn enough to be able to have their own local environment and be able to make a change, because they are having to learn the development view essentially. And if they're not given a picture, they're just trying to pull it out of everybody, and it takes a long time. All right. Now we need to decide from the very beginning of a project how we're going to run this thing. What environment types are we going to be using? And these are decisions. So a lot of these things at the beginning of our project are really decisions. We want to make sure that we have all of these things in place before we have our developers start writing code, because if they start building, figuratively, if they start building rooms on top of a foundation for a house that we really haven't solidified yet, it's just a big mess. So there's a spectrum of environments, from on-premise data center to Azure app services, and multiple different, progressively different environment types in between. On the far left, you have more control, but you also have more responsibility. On the far right, you have less control, but you also have less responsibility, less maintenance load. On the right, you don't have to patch the server. You don't have to do anything. If a server goes down, some other server picks it up. But at the same time, you have a far less control. As an example, in Azure App Services, you cannot install custom fonts. So if you're using, if you want a screen that has a QR code or a barcode or something like that, and it requires a custom font, sorry, you can't run it on Azure App Services. You need to back up one layer. You might need to back up to containers, because you can do some operating system functions on the container. But you don't need to back up all the way to an on-premise data center where you're responsible for screwing a server into a 42U cabinet. So there's lots of options depending on what mix of control and what mix of responsibility that you're willing to accept. And you need to think about those things and where you want to land. Just from a little bit of guidance, as what we tend to recommend more and more, not because we've intentionally recommending it, but just because it tends to be a really, really common recommendation, is recommending platform as a services, recommending moving as far to the right on this continuum as is possible for your software. But this is the continuum. And once you make that decision, you need to map your logical deployed components into their runtime components. So we would say that an ASP.NET UI, it can run many different places. We're going to run it inside an app service website. Then our offline job could be run as a Windows service, but you know what? We're going to package it and run it as a Azure function. And then our SQL Server database, it can be run in all kinds of different settings, but we're going to run it as a managed Azure SQL database. And then our acceptance tests are going to run as essentially as an EXE, just on a hosted agent. Now, I want to talk about the structure of your source control. Do not have more than one application in a Git repository. This is one of the rules. Don't violate it, or you will just set yourself up for lots of difficulty later on. Every product on the market in the DevOps space has this design assumption that we're working with one deployed application. Even if there's multiple components in the application to deploy, it is one application. You can have a software system that's segmented into many applications as people going for the microservices style, but each of those applications or each of those microservices is in one Git repository. When migrating from TFS or for another centralized source control, make sure that each application that's probably previously in a folder structure is broken out into its own Git repository, because you're going to branch at the repository level. Then finally, you need to look at operations, how you're going to run the software, and monitoring is a huge thing here. And so we want to make sure to centralize centralize all the logs, all the telemetry offsite from the environment, so that we don't have to grant administrative access to an environment just for someone to be able to diagnose a problem and read the logs. We want to centralize it and move it offsite. Application Insights is terrific at that. But there are 3 different types of telemetry. Logs is not enough. You also want to think about metrics and events. Effectively, if you've ever, and if you haven't, read up Kimball's data warehousing books. If you've ever created analytical reports or a star schema or a analysis cube or data warehouse, then you have implemented the same data structure and the same techniques that you need to do for runtime telemetry of your application. You need to create the fact tables that are going to allow you to ask questions of the application or ask questions of the logs, like, hey, how many of a certain function did we have grouped by hour throughout today? Or Betty reports a problem and you say, show me everything that Betty did earlier today or within 15 minutes of that problem. Events essentially are a unique name for every function that the application has, and they're strings essentially. Metrics are numbers, and they are performance timings or counts or anything else we can capture. They are always numbers because we are going to use aggregate functions on them, like min, max, sum, average. And so if you think about a SQL query, we would select the sum of some type of metric from our telemetry store, from our fact table, and then we would say where there's a filter, group by an event name or group by a time frame. And we might filter to just one event. But essentially, we're creating a data warehouse so that you know exactly what's happening with your application. Application Insights gives you a wealth of telemetry immediately after you hook it up. If you have a .NET application, .NET Core, or .NET Framework, hook up Application Insights, and it already knows Entity Framework and SQL Server and every other part of the .NET Framework, and it has automatic instrumentation everywhere. And you'll automatically get a wealth of information just by enabling it in the application's startup routine. And also, when you deploy your software from the get-go, from your pipeline implementation from the beginning, you want to include release markers, that highlighted part on the screen in the performance pane of Application Insights. This marker signifies that a deployment happened at that time, which is roughly 8 a.m. on that day. And the little dots are different usages. So as you have a heavily used environment, you'll have a line graph of dependency response time and whatnot. But you'll also get a marker for when you deployed the application. So if things start to go sideways and it was right after a deployment, you can at least have that context. And when you click on the deployment marker, it'll give you a link right back to your Azure DevOps project and all the information, the build number, whatever you pack in there. So when you're starting up a new project, think about all of these capabilities. You want to equip your team properly. Make your strategy for each one. That is, decide what you're going to do for each one. Then get it into the routine of the team. That's execution. And then measure how things are going to make sure it's getting the effect that you intended. If it's not getting the effect that you intended, then you might need to change the strategy. And surrounding your Azure DevOps pipeline needs to be all these other team capabilities. And the goal is that you can cycle through the plan, code, integrate, package, release, operate, learn. You can spin that cycle time faster and faster and faster, and your project accelerates over time. Too many times without a proper project jumpstart phase, the team starts going and the cycle times get slower and slower and slower. With this model, the cycle times accelerate over time, and you can even keep the same pace with a team of a smaller size and get people working on other projects. So overall, my hope for you is that you move fast, build smart, and run that system with confidence. We have a number of success stories. We've seen this model make a huge impact for our clients, and we have some stories available on our website, but I wanted to play just a quick snippet for you of one of them that you can find on the next slide.
Azure was with us before we launched. From the time we initially did the project with them to launch was 4 months, and it was a rapid evolution of idea to conception to reality, and they were a critical part of that. Marlette,
and you can find the rest of that case study online, bit.ly/project jumpstart story. They're a huge success story, and we helped that project jumpstart and get off on the right path really rapidly. and now they're doing quite well in their industry. One easy way to get some help is have us do a architecture level assessment or a DevOps inspection. And so our goal for you is for you to be self-sufficient. We are a software architecture company empowering software delivery, and we want to up-level your organization so that you can outsource less, in-source more, and have a more self-sufficient capability in-house so that you can deliver world-class results for your customers. Remember, get the book. Get the book. And the print book is available anywhere books are sold. And a special offer just for the live attendees of this webinar is a complimentary ebook, electronic copy of this book. And so there is a book request form in the chat that you can go and fill that out. And then I've answered a lot of questions all along the webinar, and the answers and various resources are in the chat. But I can't stress how important it is to get this book and read this book so that you can set your project out on the right track. Here's my contact information: phone number, email address, Twitter, and I believe that I have answered all the questions that came through in line as I was going through each topic. I want to thank you for your time. You have a big job. Your leadership role in your company is important. It's critical. The stakes are too high. We understand what you're going through, and we're here for you. And my hope is that you will kick off your project in the right way. You will get your team moving fast with super high quality, and as a result, you'll have a system that runs in a very stable fashion. Have a great day.